Um, Good morning, everybody, and welcome to our YouTube video of our lesson for today. It's actually not going to be a lesson. Um, for the past few days that we start the trigonometry unit, there's quite a bit of stuff that we've already covered in this particular case. Um, we've covered from angles in standard position. We talked about the reference angle. We talked about trig ratios. We talked about special angles. Um, we talked a lot about a whole bunch of stuff in this particular unit. And so um, the past few days, you were given some exercises from the book. So what I'm going to try to do is I'm going to try to go over some of those questions, um, and hopefully it can get you started. And this is a way for you to show, to see how I'm solving some stuff, and you can compare yours and so on. Okay, so I'm going to start with the questions on page 474 in exercises. I won't have time for all of them, unfortunately. So if I missed your question, and if you wanted to see how I solved that question, just let me know, and then I will, um, try to help you out with that. Okay, so question number three is basically, it says there, use technology to determine the value of each trigonometric ratio to the nearest thousandth. Um, now, so let's try that one. Use technology, meaning use your calculator to do that. So A is sine of 415 degrees. So what you have to do is to type it into your calculator, and what's the sine of 415 degrees, and make sure our calculator is in degree mode. So sine of 415 degrees, we're gonna get 0.819, because they asked for the nearest thousandth. So nearest thousandth. So the other one is cosine of negative 65 degrees. So that's going to be cosine of negative 65 degrees. Make sure we put the negative in there. It's important because that's going to give us a different value if we put a negative instead of a positive. So it's going to give us negative 0.4223, because we have to round it off to the nearest thousandth. Now we come across this one in here, cotangent. And this one here is not as easy to do, because when we say like, hey, cotangent, what does that mean? I don't even have a cotangent button on my calculator. But remember, our cotangent is the reciprocal of tangent. So what we're going to do is we can first calculate tan of 72. Okay, and then we're going to get zero, no, not zero, oops, 3.07768, and a whole bunch of numbers after that. Now, that's not what the question is. That's the tangent of that. So we know that cotangent of 72 degrees is a reciprocal 1 over the tangent of 72 degrees. So once we have that, okay, well, we know tangent of 72 is this amount. So it's going to be 1 divided by tan of 72. So if you want, you could take 1 divided by this number, or I'm just going to go 1 divided by the 10 of 72. And I'm going to get 0.3225 because it's nearest 10th. And last but not the least, the cosecant of 285 degrees. 85 degrees. Now you're thinking, oh no, I don't have a cosecant button on my calculator. Well, what does cosecant mean? Cosecant is the same thing as 1 over sine of 285 degrees. Okay, because it's a reciprocal of sine. So it's going to be 1 divided by sine of 285 degrees. And we're going to get a negative 1.035. Okay, so that just, like the first two, it's just basically, hey, I'm just going to type this in onto my calculator. But then the C and the D kind of set us back a little bit and say, we made us think about, well, what is a cotangent again? What is a cosecant again? So that's how you would do that one. Okay, so now we're gonna go to question number 4. And question number 4, I won't be able to do all 4 of them, but I will do 4. I'm just gonna do 4C and 4D. Okay, so I'll try 4C and 4D and we'll see. Now 4C, what the question says, sketch the angle and identify the reference. So sketch theta, whatever the angle that they're giving us, and state theta r, reference angle. So what does that mean? I'm doing 4C first. So 4C, they're telling us that theta is 695 degrees. Okay, so 695 degrees. What does that mean? That it means that our angle is a positive angle. Well, what does that mean, a positive angle? It means it rotates in a counterclockwise direction. This is going to be over 360 degrees, so that means it's going to rotate more than 1 revolution. So what does that look like? What does that look like? So let's see. We know 695 degrees is going to be over 1 revolution, so or 1 full turn. So 695, and I think I did this strategy when we talk about this in lesson 1. I did a long division, 695 divided by 360 degrees, because 1 full runaround is 360 degrees. So if I take 695 divided by 360, that's going to give me 1 full revolution. So 360 over here. And that's going to be 5, that's going to be 3, and then that's going to be 3. So what does that mean? What did I just do in here? So this one tells me I went full circle, full circle, or 1 revolution. And then I did 1 full revolution, and then 335 degrees is, I have to turn a bit more. So I have to turn 335 degrees more. Okay, so where am I gonna go? What does that look like? So I'm turning around 1 full revolution, and then I'm going to turn around this much more. So this is my 1 full revolution, and then I'm going to keep going until I turn to 335 degrees. So where's 335? So this is 0, 90, 180, 270. So 335 would, and then going back here is another 360. So 335 degrees will make me land somewhere over here in quadrant 4. So that's That's my run around, one full 360 and quite a bit more, 335 degrees to make a 695 degree theta. So what does that mean? What is the reference angle? So the reference angle, we said last time, is the angle, reference angle is the angle between the terminal arm, where your arm stops, and the x-axis. So here, okay, so this is our theta r. Okay, so how far is that? So theta r, so in quadrant 4, theta r, okay, is going to be 360 minus 335 degrees. So that's going to give us 25-degree reference angle. So this angle in here, within this triangle in here, that's 25 degrees. 25 degrees. Okay, so that's 4C. 4C. Now I'm going to do 4D. Just going to grab some more paper in here. 4D. Now this is going to be on page 475, and that's going to be question 4D. So 4D says our theta is going to be negative 500 degrees. Okay, so what we're going to do is we're going to sketch that, figure out where that is, and also find out the theta r reference angle. So our job is to sketch and theta r. So what does that mean? This is a negative angle. That means we're going to turn clockwise in this direction. Okay, clockwise. Clockwise. So I'm going to start my arm right on the positive x-axis, and then I'm going to turn around 500 degrees this way. Okay, counterclockwise way. So how do I do that? Well, that's going to be more than one run around, one full run around. So what does that look like? This is how I normally do it. So I could go, hey, I know that this is going to be negative 500 degrees. And then and I'm sticking with the negative there. And if I go one full run around this way, I'm going to go negative 360. So how many runarounds am I going to go? Or full revolution? So negative 500 divided by negative 360, I can only go one full round. So positive 1. That means one full around this way. And then this one times negative 360 is negative 360. And I'm supposed to subtract that. Okay, so negative 500 minus negative 360, I'm going to get negative 140 degrees. So that means I'm going to have a one full turn this way, one full turn, and then I have to turn negative 140 degrees more. Turn negative 140 degrees more. So what does that look like? So this is my initial arm, and then I'm going to go full one turn around, full one turn, and then I go a negative 140. Well, where's a negative 140? So 0, I know that's, if I do a negative turn, I'm going to go, this is 0, this way is negative 90, this is negative 180, this is negative 270, and then if I go all the way around, negative 360. So where is negative 140? So negative 140 would be somewhere right in this quadrant. 140. So this quadrant. So this is my terminal arm. So I started off at the positive x-axis and then turning clockwise 500 degrees and it landed over here. My terminal arm is somewhere in quadrant number 3. Quadrant number 3. So what's my theta r? So theta r, reference angle. Okay, so how big is my reference angle in here? Theta r. Okay. And theta r is always positive. Um, it's where the terminal arm is in between the terminal arm and the x-axis. So this is our x-axis right here, and this is the terminal arm. So this is the angle that we're talking about. So how can we figure that out? This is how I do it. I go from large angle to a smaller angle, subtracting them. So it's going to be negative 140 minus negative 180 degrees, because this is my negative 180. So theta r, negative minus negative, that's going to give us a positive 40 degrees. Positive 40 degrees. So this theta r right here is 40 degrees. Okay, so I've done so far question number 3, question 4C, and question 4D. I'm going to try to do as much as I can. Like I said, I won't be able to do everything. Okay, so now what I'm going to do is I'm going to take a look at question number B, 5B, and 5C. 5B, and then I'm going to also do 5C. So what does 5 asks of us? Question number 5 says, determine the measure of angles that are coterminal with the angle in the given domain. Okay, and then write the expression of the measures of all the angles that are coterminal with a standard position, in a standard position. So, there's quite a bit of stuff that they're wanting us to do. So I'm gonna write down here. They gave us an angle. An angle. They gave us an angle of negative 105 degrees. Okay, negative 105 degrees. It's always best to have a visual of what you're looking at. So, okay, and then they're saying that we're looking for a coterminal for that. Coterminal for the domain of negative theta has to be between um, negative 600 degrees and positive 600 degrees. Okay, so let's see what that one looks like first. What that one looks like. So this one is a negative angle, so that means we're starting at the positive x-axis right here, and then we're gonna turn clockwise. So this is 0, and if I turn clockwise, that's gonna be turning in a negative way. So this is negative 90, this is negative 180, and then this is gonna appear as negative 270. So where is negative 105 degrees? So negative 105 degrees is going to be closer to negative 90. So it's going to be somewhere over here. Okay, so this is going to be negative 105 degrees. Now, we can see what that is. So what we're going to do is we're going to look for coterminals. Coterminals. How can we figure out the coterminals of this angle here? Coterminal means even if you run around or go around a few times, either clockwise or counterclockwise, that means we're going to stop in the same terminal arm. So that's what coterminal means. So in lesson one, we talked about the formula to find the coterminals. So the formula for coterminals is formula for coterminal is theta, whatever the theta is, plus 360 degrees times k. And then what does k mean? Well, k is any value of integer. So that means that if I put a k of 1 in here, that means I'm going to go around 1 revolution. If I do k is 2, then I'm going to go around 2 revolution. And if I go around 1 full turnaround, I'm going to come back to this one. If I turn around 2 times, 360 times 2, I'm gonna stop right here. So that's why it's K. It tells us how many revolutions of how many turns do I need to go around. So what we're gonna do is, because I have to find all coterminals between 600, negative 600 degrees and positive 600 degrees. So I'm gonna just put some values for K in here for our purpose. So I'm gonna go negative 105, because that's the theta that they gave us, plus 360 times negative 2. I'm going to start with the negative 2. And let's see what that is. Negative 105 plus 360 times negative 2. That means 2 run around full revolution, 2 full circles in a negative direction. So I'm going to get a negative 825 degrees. Okay, I'm going to do a few and then negative 105 plus 360 times negative 1. That's going to give us negative 465 degrees. Negative 105 plus 360 times 0. Now you're probably seeing here, these are my integers, negative 2, negative 1, 0. That's going to give us negative 105 degrees. Because negative 105 plus 360 times 0 is negative 105. Negative 105 plus 360 times 1, that's going to give us 225 degrees. Oh, so no, 255 degrees. Negative 105 plus 360, 255. Let's fix that one. 255 degrees. And then I go negative 105 plus 360 times 2. I'm going to get 615. Okay, so negative 105 plus 360 times 2. I'm going to go 615 degrees. Okay, so these are the ones that I've tried. Like K are the integers that I've tried, negative 2, negative 1, 0, 1, 2. Now, I have to look for a all of these are all coterminals, but because our theta is between negative 600 and positive 600, so this one, we have to cross this off. This is not going to be part of our solution. It's the right coterminal, but it's not within our domain. So the only coterminals within the domain are negative 465, negative 105, and 255. So the coterminals are negative 465 degrees, negative 105 degrees, and 255 degrees that are between negative 600 and positive 600 degrees. Okay, because that's our domain. Okay, so just stating. Okay, so that's 5B, 5B. Now let's take a look at 5C, because 5C is a little bit different. It's not that different. It's a positive. So going through 5C. So this is going to be on page 475 again. And then this is going to be 5. Did I say 5C? 5C. Okay, so 5C, they're telling us that the theta is going to be 215 degrees. The angle in standard position is 215 degrees. And what we're trying to figure out are the coterminals for the angles negative 700 to positive 700. So we're looking for coterminals between negative 700 degrees and positive 700 degrees. So it's very, very similar to what we've done in part B. This is the only thing. The difference is that this is a positive angle. Okay, so where is 215 degrees? It's always best to have a picture in front of you. So this is a positive angle, so we're going to turn counterclockwise in this direction. So 0, 90, 180, you know this. And then go around this 270 and then all the way around to 360. So 215 degrees is actually going somewhere in a quadrant number 3. So you're going to turn, this is your initial arm on a positive x-axis, and then you're going to turn this way to make it to turn to 215 degrees. So we are going to end up in quadrant number 3. So looking for the coterminals. So formula for coterminals. And this is basically the general solution for coterminal is going to be theta plus 360 times k, where k is an element of z, or z there means integer. So theta is 215 degrees plus 360 times k, where k is an element of an integer. Okay, so what we're going to do is we're going to try to figure out the coterminals within this domain, negative 700 and positive 700. So let's use this one in here. So I'm going to try some. I'm just going to go negative 2. And let's see what that is. 215, 360 times negative 1, whatever that is. 215 plus 360 times 0. Well, that one I know, 215. 215 plus 360 times 1. 215 plus 360 times 2. Okay. So in this particular case, I'm just going to calculate this part over here. So 215 plus 360 times negative 2. That's going to be negative 505 degrees. 215 plus 360 times negative 1. That's going to be negative 145 degrees. 215. Okay. So all of these are coterminal for 215 degrees. But the thing is that some of these don't fall within the domain of negative 700 degrees to positive 700 degrees. So this one falls into that category. within that domain. This one also falls within that domain. This one falls right into that domain. This one falls right. And then this one here, this is not going to be part of the solution. Oh, sorry, you can't see that. This is not part of the solution because it is over the 700 degrees. So therefore, the coterminals are negative 505 degrees, negative 145 degrees, 215 degrees, and then 575. And those are the only ones. There's other coterminals, but these are the only ones within that specific domain. Now, this is going to be super important to understand, just to let you know. It looks like we're really not like, what is this about? Where is this going to lead to? It's an important groundwork when we talk about solving trigonometric equations. Really good at this thing and really understand it. You cannot memorize things, unfortunately. You have to understand it. Oh, you can memorize it, but memorizing doesn't go very far. Okay, so that's number 5. Okay, so I'm just going to fast forward a little bit. I'm going to speed things up because I don't really have a lot of time. Now, what I'm going to do is I'm going to take a look at question number 7. Question number 7 in here. I'm just going to do question 7A. 7A, and then this is now on page 477. Question number 7A is that we're given an angle. We're given this angle of 480 degrees, and then what we're trying to figure out is what are the exact trig ratios. Okay, now what we're gonna do, we can't just type in well, we could type it in, but then if we type this in onto our calculator, it's not going to give us the exact value. So how do we figure out the exact trig ratio? So again, visualize this one. Where is this within our grid? So 480 degrees, 480 degrees is where? This is going to be over our one revolution, one going around. So that I'm going to go 480 divided by 360. So that's the very first thing that I'm going to do. That's going to be 1. That's 360. That's going to give me 0 to 120 degrees. So that 480 degrees tells me that I'm going to go around one full revolution, and then I have to turn 120 degrees more. So where's 120 degrees more? So 0, 90, 180. So 120 degrees would be somewhere right here. Right there. So we go around one full revolution and then 120 degrees more. And then this is where I ended up with in quadrant number 2. Now, this happens to be because if they ask for an exact solution, it must be a special angle. Okay, so we talked about yesterday the special angle. So drop this perpendicular line there, and it's going to be within the unit circle. Our reference angle here. Okay, so if this is going to be 120 degrees, then the reference angle within or inside that is 60 degrees. So what we're going to do is we're going to use our reference angle 60 degrees to determine the trig ratio. Okay, so this is a special angle that we talked about yesterday. So let's just see what that is. Along the x is going to be the cosine, the y would be the sine, and then from there we can expand the tangent, secant, cosecant, and then cotangent. So in this particular case, we don't need any points on these ones because it's a special angle. We know that the x is a cosine of the angle. So cosine of 480 degrees is going to be as you can see, it's going to be in the negative side. So it's going to be a negative. What would that be? Negative 1/2. Okay, so negative 1/2. How did I know it's negative 1/2? We could go back and take a look at our notes from yesterday. Okay, so this is negative. I don't have my pencil here. Where's my pencil? Oh, there's my pencil. If I'm gonna put this into my unit circle, okay, embed it in the unit circle, and this 60 degrees, that's basically about a halfway from here to here. This is a 1 unit circle. So this is about halfway, but going to the left, so it's negative 1/2. Sine of 480 degrees, that's the y right there. It's going to be √3/2. And then the tangent, tan of 480 degrees, is sine divided by cos. So sine divided by cos. Tan is opposite over adjacent. So y is the sine, x is the cos. So sine divided by cos. So sine divided by cos, I'm going to get √3. If I take √3/2 divided by 1/2, it's going to be negative √3/1. √3/1. And then from here on, the secant, cosecant, and cotangent are just reciprocals. So if once we know what the cos is, we can go secant 480, and that's going to be just a reciprocal. So it's going to be negative 2. Oops, running out of room in here. 2/1. Just I can put the 1 here, or I don't have to, but I just wanted to show that it's going to be reciprocal. Cosecant of 480 degrees is going to be the reciprocal of sine, so it's going to be 2 divided by √3. And then cotangent 480 degrees is going to be a reciprocal of tangent, so negative 1/3. Okay, so that's 7A. Quite a bit of this alone, this question has so much understanding of this topic. Okay, it talks about angle in standard position, reference angle, the cos, sine, tangent, trig ratios, basically. It's quite a bit of stuff. This is a loaded question. Okay, so that's 7. Now, I'm going to try to jump to question number 8. Question number 8. Let's see here. Like I said, I don't have time for all of the questions, but I'm going to try to do some. Page 77, 477. Question number 8. Okay. How is this one different? For question number 8, they're actually giving us the point. So the given point. Okay, the point is 2, 1. And that 2, 1 is within that unit circle. Okay, we can think about that one. Well, not within the unit circle, but um, it's we could plot it and then figure out the trig ratios here. Sorry, I don't want to confuse people. So given that the 0.21, the 0.21 is within the terminal arm. So what we're going to do, okay, so what are they asking for? Determine exact trig ratios. Okay, so how do we do that? We need to visualize things. Okay, so where is this one here? So 2, 1. So 1, 2, 1. So this is our point. So that's our point, and that point, the terminal arm goes through that particular point. So what does that mean? Okay, it means that we can drop that line here. So we know the y is 1 and then the x is 2. You know, the x is equals to 2, y equals to 1. The very first thing that we're going to need is we're going to need to figure out the r, how far the radius, they call it r because it becomes a radius of a circle as it goes around. So r, and then you can think of that, hey, that's the hypotenuse. So I'm going to take a look at, I need to calculate the hypotenuse for this one. So use Pythagorean theorem to calculate r. Okay, and that's the r right there. How do we do that? So r squared is equals to 2 squared plus 1 squared. So r squared is equal to 5. So therefore r is the root of 5. Okay, so now I know r is the root of 5. Okay, is equals to the root of 5 there. So from there, okay, and then my theta. Where is the theta in all of these things? So the theta in standard position, the theta in standard position is right here. Theta in standard position is right there. So we're going to go cos theta. We don't know what the theta is. We don't know what that angle, tiny angle there in standard position. It's going to be adjacent over hypotenuse. So that's going to be 2 over root of 5. 2 over root of 5. Sine theta is opposite over hypotenuse. So it's going to be 1 over root of 5. And then tangent is going to be, tangent of what? Tan of theta is sine theta divided by cos theta, which is 1 over root of 5 divided by 2 root of 5. Okay, now you can see that root of 5's cancel, so you're left with 1/2. So tan theta is 1/2. Now that we've established all this 3 primary trigonometric ratio, we can do the secant theta, and secant theta is just a reciprocal of cosine. So it's going to be root of 5 over 2 sine. Reciprocal of that is cosecant theta. So it's going to be root of 5 over 1. Okay. You can put just root of 5, but I'm putting root of 5 over 1 so I can see that they're reciprocal of each other. And then the cotangent theta is equal to the reciprocal of tangent. So if tangent is 1 over 2, cotangent would be 2 over 1. Okay, so that's question number 8. Number 8. 8A. This is number 8A. You could try question number 8B, but in that particular case, you're gonna pretty much do the same thing. Okay, how much time do I have? I have about 15 minutes. I'm gonna try to limit this video for about an hour. So I'll try a little bit more. Okay, I'm gonna try some questions. Okay, I'll try question number 11. If you have a specific question that you want me to do that I did not go over during this video, please let me know and I'll try to go over them. But I'm going to go over question number 11. This is on page 478. I'm going to do question number 11. I'll do 11A. Okay. And if I have time, I'll do 11B. Okay. So question 11A, this is again another loaded question. So much stuff that they're doing here. So it says for each of the value of trig ratio, so this is what we're given. We're given that the sine of theta is equals to -1/2. And they're telling us that this theta here, this theta that they're talking about here, is within the -360 degrees to +360 degrees. Okay, so what are they asking about? They're asking about determine the possible measures of theta. So what are the possible values of theta that will give us that sine of theta is equals to -1/2? Okay, now what does this mean? What does sine of theta equals to -1/2? So this one, the sine of theta, is actually the y value within the unit circle. So sine theta gives the y value, y coordinates, or coordinates. Okay, so they're telling us that if this is the unit circle, sine is 1/2. So that means unit circle means everything in here is 1 unit. The radius of the circle is 1 unit. So this is 1 unit, this is 1 unit, and so on. So where is y -1/2? -1/2 would be here. So the point is right there. Oops, I missed that one. So it's gonna, if I turn this way, the y is gonna be -1/2 here. This is -1/2. So where is that gonna be? It's right there and right there. Now, what does that mean? Well, sine of a -1/2 is actually a special angle. This is going to be a special angle, special reference angle in here. So what is that special reference angle? That's going to give us 30 degrees, 30-degree angle, the reference angle. reference angle there. Okay, so negative 1/2 for sine, that's the y value, y coordinate, and that is a special angle. You might recognize that already, which was covered in grade 11 pre-cal as well, is that so special angle is 30 degrees for reference angle. So what does that mean? Well, what's the angle in the standard position? So I can go from here to there. So in theta, in quadrant 3, okay, in quadrant 3, theta in this case is going to be 180 plus 30 degrees. So that's going to give me 210 degrees. 210 degrees. And then I'm going to leave a space in here and I'll show you why. Now, I have another one over here in quadrant number 4. So in quadrant 4, theta is going to be, if I go from standard position right there all the way to this terminal arm, initial arm to terminal arm here, that's going to be 360 minus 30 degrees, which is 330 degrees. So as you can see, that's 210 and 330 degrees are within the domain. This is the domain, negative 360 to positive 360. Now, are there any other numbers, or are there any other angle that's coterminal to these ones? So we're back to finding the coterminals. So coterminal for that 210 degrees. So let's go here. 210 degrees plus 360 times negative 1. Okay, where would that be? $210 plus, this is going to be negative 150 degrees. 210 plus 360 times 0. That means I'm not turning anywhere. So it's just going to be 210 degrees. And then 210 degrees plus 360 times 1. 210 plus 360 equals to 570 degrees. Okay, so all of these are coterminals of theta 210 degrees. But which one of these coterminals are within the domain? So this is within the domain. Negative 150 is within the domain. This one is yes, and then this one is not within the domain. So we're not going to include that one. Now let's take a look at the last piece, 330 degrees. So our angle is 330 degrees plus, we're going to look for the coterminals of these things. 360 times negative 1, that's going to be negative 30. 330 plus 360 times 0, so that's going to be just 330 degrees. And if I go 330 plus 360 times 1, I'm going to go way over. So I'm just going to calculate that. I know it's going to be over 690 degrees. So this one, negative 30 degrees, is within the domain of negative 360 to positive 360. 330 degrees is within the domain of negative 360 to positive 360. So all solutions, therefore, theta are, okay, so theta are negative 150 degrees. I'm just going to write it down from smallest to biggest. Doesn't have to be any particular order as long as you have them. But so negative 150, negative 30, 210 degrees, and then the other one is 330. Okay, so there you go. So those are all of the four possible solutions to these ones. Um, Now, so those are all of the four possible solutions to these ones. Um, I don't have a lot of time, and I don't have time for the other ones. If you know, I went over a few questions. I didn't go over all of them. So if there's a specific question that you want me to take a look at or want me um, to discuss, let me know, and then I'll try to answer your questions if there's something in here that you want me to go over. Anyways, so today would be a good time to just finish off all of those questions that were given to you. And if you happen to be stuck on anything, please send me an email, and I will try to get back to you as soon as I can. And yeah, maybe um, yeah, I'm sure we can work out the solution for whatever question that you have. But anyways, today would be time to just finish off everything that you need to finish off. Tomorrow we will continue on with the lesson, um, on lesson number 3. And as you can see, we're getting really fast on this booklet. And then I will let you know as well when your test is going to be for this one. Okay. For the meantime, leave that with you. Try some questions on your own, and then I'll talk to you again tomorrow. Okay. Have a great day, everybody, and yeah, thanks for watching. Okay. Bye for now.